Okay, you're gonna take out your whiteboard, your pen, marker, and eraser. You're going to draw some scenarios based on what I show you. Okay? Okay, what you're gonna do is you're going to sketch the graph and you're going to label the axis. Sketch the graph, label the axis. Okay, first scenario. The age of a human from birth to 30 years old, the independent variable is time. The dependent variable is age. Go ahead and graph. Remember to label. That way I can see. Okay, so the age of a human from birth to 30 years old, time is the independent variable. Age is the dependent variable. So graph it. Okay, good. So pretty much all of you drew this. You said this is years of time. And then you said this is age, also in years. And then you said it's linear. Okay, let's ask you a question. Is it guaranteed that there was some time t that this person was 17 years old? Is it guaranteed that this person was 17? Yeah. How do you know? Okay, age is continuous, and then what? You had this graph from birth to 30 years old, though.
Yeah. 0 to 30, and it's continuous. So that means there must be a point because of that one theory that we learned about in the age.
Because
the limit of c from the negative. Oh wait, shoot. What is it?
It has nothing to do with limit.
What's the theory called?
Hold on, raise your hand. Too many people talking. Yes.
It's like the intermediate theory.
Okay, well, explain to me how that's applied.
Okay, basically, if you have one spot and then you have another spot and it's continuous, then it's going to have to go through the middle.
Okay, it has to go through not just the middle, but it has to go through what? The number that you want.
Yeah.
Right? The number you want, if that number is in between, right? Okay, now let's look at another scenario. The height of a child with respect to days means days are your x. From 5 to 10 years old. Independent variable is time. The height is in feet. What do you think this is going to look like? Please draw it. Okay, so a lot of you, it's kind of interesting what you guys drew. First of all, I said from 5 to 10, right? So I think some of you kind of did like this anyways. I hope. At 5 years old, you are not still here. Okay, 5 to 10. So if you do this, I guess you're very consistent from 5 to 10. I don't know. But, some of you said like this, around 10 you grew a lot faster. Or you did this, you're like at 10, I didn't really grow anymore. I don't know. But the question is, if the child were 3'8" at 5 years old and 5'2" at age 10, a really tall child actually, is it guaranteed at some point between 5 and 10 that child was 4 feet and 5 inches tall?
Yeah.
Yes, why? Oh, don't tell me intermediate value theorem. Tell me why. Why does it work? What's continuous? All right, maybe we should raise your hand because
Because you started at 3.8 and you have to end up at 5.2. If you do that, you have to pass 4.5.
Why does it have to pass 4.5? Because Gary's did not.
Because height is continuous.
Height is continuous. Okay. All right. All right. A car exits WCHS parking lot onto Beach Boulevard at 10 miles per hour. 20 seconds later, the speed of the car is 45 miles per hour. Okay, go ahead and draw. So most of you guys drew something like this, right? So 10 to 20 seconds. Oh, no, sorry, 0 to 20 seconds. And then you started at 10 miles per hour, you end up with 45. Okay, again, the question, is it guaranteed that at some point between the car exiting WCHS and the noted time of 20 seconds later, the car traveled at a speed of 30 miles per hour?
Yes.
Yes, why? Raise your hand. Gainer.
It is, it has to go at 30 miles per hour at some point because it started at 10 miles per hour and it ended at 45 miles per hour. And the speed gaining is always continuous.
Okay, that's what I'm looking for. The speed is continuous. Okay, so it must go through. So let me ask you one big question. What two conditions do these three scenarios have to have before the guarantee is met? Okay, Elizabeth.
Dependent variable is continuous.
Dependent variable is continuous.
Or like the graph is
Okay.
The independent variable is continuous.
Okay, well, what's another way of saying all that? William?
The number is in between two existing ones and it's continuous.
Okay, all right. That's the second guarantee. Okay, Peter.
The function is continuous.
Okay, good. The function is continuous. Okay, the function is continuous. That is the first requirement. You gotta have that. And then, what is the second requirement so that there's a guarantee? Yes.
It has to be between two existing numbers.
Oh, okay. So one thing we're going to do in this class is we're going to take out the word it. It is too ambiguous. I don't know what it you're referring to. No more it.
The point we're looking for
The point we're looking for,
has to be between a number smaller and greater than n.
okay, the number we're looking for has to be between the two endpoints that were given, right? Okay, so basically we were saying like if the two endpoints were f of A and f of B, what you're looking for, let's say f of C, is in between.
You write on the whiteboard or something.
You have a question? Right, then we don't know. Basically, if it jumps and it comes back, then we have no idea. If it's so basically, if all you know is that there are 2 points, and you know it's continuous, they said, is there a point that was here? You say, I don't know, because I don't know if the graph goes like this, but I know the graph has to go like that. Yeah? Question?
It has to be less than and greater than, right? What if the graph's like that though? Because then it would be.
Then we don't know. Yeah, that's the same thing as Sophie's question, so we don't know.
Okay.
Yeah, the theorem does not guarantee. Okay, so we'll talk about that, but these are the two main things, right? First, continuous. Second, the point that you want is in between those, right? So take, for example, this question that I asked you about your driving. You know when you exited, it was 10 miles per hour. Some point, 20 seconds later, it was 45. The question is it guaranteed you went 60 sometime? No, because we don't know if you went fast and then, but we know it has to go through the intermediate, which is in between 10 and 45. Does that make sense? So a lot of you had that question. It's not guaranteed. Maybe, maybe not. But what's guaranteed is that number in between. Okay? All right, 2 requirements. So WSQ, most of you got it right. Some of you got it wrong because you said it is guaranteed. There was a 0, but it's not. No one said that function was continuous.
Yes.
Yeah, so some of you says yes, if it is continuous, that's good. Some of you just says yes because it is continuous. No one said it was continuous. Okay? All right, intermediate value theorem. All right, we have 3 big theorems this year. You have to memorize all 3. So this is the first big one. The intermediate value theorem. You can always write IVT for short. Okay, so IVT is a commonly accepted acronym. So if you just write IVT, it's fine, but it's intermediate value theorem. That's theorem number 1. Eleanor.
So what's the other 2?
We'll talk about it later. Yes.
So does that mean that we can write IVT on the test?
Yes. Okay, intermediate value theorem. Intermediate value theorem is what we call the existence theorem. Existence theorem means that you are not actually using it to solve anything. You are using it to prove something. Okay, so all our theorems are existence theorem. So you're just proving the existence of something else. It is not to solve things. So most things I teach you in math, you are solving, right? You're solving for X, you're solving for Y, you're solving for this and that. But theorems are used to prove something. So all you're doing is proving. You're like, where's my answer? Your answer is the proof. You prove something, works, that's good. Okay, 2 things. on the intermediate value theorem. So, first thing is if f is continuous on the interval a, b. Okay, the things, so in this class we're going to do a lot of theorems and, requirements, things like that. Things you want to keep in mind of is the requirements. They're always going to tell you what's required. So they're always going to say, this only works if f is continuous, which is usually the requirement. This only works on open or closed interval. So those are things you need to be aware of, like, is it here? Is it for continuous? Is it only for discontinuous? Is it only for closed interval? Those kind of things. So pay attention to that. Yes?
Do you need brackets or?
Yeah, brackets. Sorry, these are brackets.
Can we use parentheses?
No. So it's continuous on the interval closed, a and b. And then that's f of a not equal to f of b. So that was kind of what William was asking. So if he showed me this graph that says, if you have this parabola that looks like this, is a guarantee that there is a point here? No, because these 2 points are the same, right?
Where did you just mark? I didn't
Oh.
see.
So basically,
Oh,
if they
okay.
give you 2 endpoints, they're exactly the same. It's a guarantee there is a point that's a little bit below? No, because
Straight line.
there it's it's a straight line. You have to have some number in between those 2 endpoints. Okay. All right. So that's the first thing. It's continuous on that interval, and those 2 endpoints are not the same number. And the second requirement is k is anywhere between f of a and f of b. So k meaning a y value, and that y value is somewhere between f of a to f of b. So it has to go between, therefore the intermediate value. If those 2 requirements are met, then there is at least one number C, at least one number. There could be 2, there could be 3, there could be multiple, but at least one. Number C in A and B such that f of C equals k. There must be at least one number, C. That C number is between A and B, so that f of C, meaning the y, is equal to k. K is that number in between the 2 y's that you want. Okay, so let's solve some questions. Let's do some proofs. Use the intermediate value theorem to show that this function has a 0 between 1 and 2. Okay, this function has a 0 between 1 and 2. So let's think about our intermediate value theorem. So the first requirement of intermediate value theorem is what? Raise your hand. Okay, Daniel.
You have to be continuous on the interval.
Okay, good. It has to be continuous on the interval. Well, what's the interval? Raise your hand if you know. Okay, Peter? 1 to 2, very good. And we're close between 1 to 2. Okay, so the question is it continuous between 1 to 2? Yes?
Yes, because didn't you say all odd things are continuous?
All polynomials are.
Yeah, polynomials.
Yes, correct. Yes, question.
Never mind.
Okay, so it is continuous between 1 to 2. That's all we need to care about. If there is some function that's not continuous in nature, but it is continuous within that interval, that's intermediate value theorem still works. Anyways, okay, so that's true. Second requirement of intermediate value theorem says what? This one's a little bit trickier because we have not tried it. Yeah, Peter?
So it says k is anywhere between f of a and f of b.
Correct. K is anywhere between f of a and f of b. Well, what number is k? What are we looking for?
0.
0. We want k to be 0. We want that y value to be 0. that 0 has to be between f of A and f of B. Well, what is f of A? So we know k is 0. So what is f of A? What does A mean?
One.
1, the first end of the interval. So f of 1. Okay, f of 1, put in 1. 4 minus 6 plus 3 minus 2. Yes, question?
Is it possible for a odd graph to not get 0?
Yes. No, it's not.
Okay.
All the odd degrees have to touch 0 once. Okay, this is going to be what? Minus 1? Okay, f of b. What does f of b actually mean? F of 2. Okay, so put 2 in there. 4 times 2 cubed minus 6 times 2 squared plus 3 times 2 minus 2. Don't use calculator. Do it in your head. 32 minus 24 plus 6 minus 2. Huh? 12? Okay. All right, so is k in between?
Yeah.
Yes. So it's a guarantee that there must be a number c so that f of c is equal to 0?
Yes.
Yes. As long as it meets those requirements, just confidently say yes. Don't try to go back and guess yourself anymore. Yes. If you meet the requirements, yes. Now the question is, how do you actually write this out? So this is a little long, and that's why on your homework you gotta keep writing it over and over and over until you memorize how to write this form. So you say, something like, because f of x is continuous between 1 to 2. Okay, so that's your first requirement. You don't actually have to mention your f of 1 not equal to f of 2. And the second requirement. Okay, so f of 1 is lower than f of 2, right? Because f of 1 is giving me a negative number, f of 2 is giving me a positive number. Please make sure you write it correctly. Sometimes the endpoint, the second endpoint is actually lower. Please don't write it wrong, okay? So f of 1 is less than 0, less than f of 2. This next part is very important. According to IVT, if you don't actually cite the theorem, they're going to say, well, great for you. You kind of made up your own theorem in the meantime. But you cannot do that. You have to say according to IVT. How did you know that it will work? According to IVT. Okay, there is a number C such that f of c equal to 0. Because f of x is continuous between 1 and 2. That's my interval. Second requirement. And f of 1 is less than 0, less than f of 2, meaning 0 is stuck in between. According to IVT, got to have that one. So now write your conclusion. There is a number c such that f of c is equal to 0. Yes?
And the conclusions sound different, like there's a 0 in between. Or there must be a 0.
There must be a 0 such that f of c. So you got to write that c, which is like the number you're actually trying to solve. Okay? So, yes?
For the part of the continuous, do we have to prove it or we just say it?
No, usually you can just say it. All right. Okay, let's look at this one. You have to decide if intermediate value theorem applies. If it does, then we are actually going to just write out that intermediate theorem proof. Okay? So let's look at it. Can we apply the IVT?
No. We
10 seconds, talk to your partner. Can you apply IVT? All right. How many people says yes, we can apply IVT? How many people say no, you cannot apply IVT? Okay, the answer is yes, you can. Why?
Because K is at 6.
Because when you plug in
Because it's
one,
not at 0.
It's not at 0. It's not continuous at 0, but we're not going to figure out the interval at 0. We're interval from 1 to 3, which is continuous. So it's fine. Okay? So, yes, it is continuous. So we can. Now, second thing, we got to check if 6 is in between f of 1 and f of 3. Okay? F of 1, f of 3. Is 6 in between is the question. Go ahead and check.
1 plus 4 plus 8. 9 over 1 is 9. And
9 and
17 over 3.
yeah.
17 over 3. So the question is 6 in between?
Yeah.
I don't know what 17.
17 over 3 is almost 18 over 3, right? 18 over 3 is 6.
Okay.
So yeah.
Yes, it is. So now write your proof. Because blah, 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 and blah, 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 according to IVT, so there must exist blah, blah, blah. All right, so let me help you write this. Okay, so something like because f of x is continuous on 1, 2, 3. That's important because f of x is not continuous, but it is continuous on 1, 2, 3. And which one's lower? F of 3 is lower. Please check. F3 is lower than f of 1. Okay? Please write your inequality correctly. According to IVT, there must exist a C such that
C is 6.
f of C is 6. Correct. So if you do want to figure out what number is going to equal 6, make this equal 6 and solve. Right? There is a way to solve it, which you learned before.